Hey there, everybody. In this video, we are going to talk about factorial. Factorial is a very important concept in mathematics that has to do with counting things. You might think, counting, how can that be complicated? Well, if you have to count some very basic things like how many ways are there to shuffle a deck of 52 cards? Think about that. It's not that easy to figure out. And if you have to count, say you have 3 people running a race, how many ways can they finish first, second, and third place? And the example that we're going to look at is we are going to have 4 marbles of each of a different color. How many ways can we arrange these 4 marbles? I'm going to make a guess, and then we're going to go figure out. And we're going to use factorial to explain the final answer. Okay, so here we are. We have our 4 marbles over here. And I want to count how many ways I can arrange these 4 marbles. I got a blue marble, orange marble, green marble, and a yellow marble. Well, when we pick the first marble, it can be one of 4 different colors, right? It can be the green one, the yellow one, the blue one, or the orange one. Okay, well, once I've picked the first marble, what are my options for the second marble? Well, if I picked the orange marble here, there are 3 colors remaining. And the same thing for the blue, yellow, and green. So when I pick the next marble, there are 3 possibilities. Now that I've picked 2 marbles, say I picked the orange and the green, how many possibilities are left for my third marble? Well, there's 2 colors left. And that's the same for every single one of these outcomes that we've already illustrated here. So there's 2 for each of those. Now that I've picked those, how many options are left for the last marble? Like for the instance, in this case, we picked orange, then green, then blue. The only possibility is 1 more marble. And that's the case for every single one of these arrangements. There's 1 additional color that we could choose. So each one of these branches here describes 1 selection of the 4 marbles. Here we've got orange, then green, then blue, then yellow. The other branch is orange, then green, then yellow, then blue. We're counting those differently. The order matters. Then we have orange, then blue, then green, then yellow. These are all different. Or I could have done yellow, then blue, then orange, then green. All of these different possibilities are different orderings of these 4 marbles. So how many do we have in total? Well, to compute that, we can just count the number of end branches that we have. 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4. So 24 total arrangements of those 4 marbles. And we call this 4 factorial. Factorial, represented by an exclamation point, denotes the number of arrangements where order matters of that many things. So n factorial represents the number of ways that we can arrange n objects where order matters. So with 4 marbles, the number of ways we can arrange them is 4 factorial. If we had 3 people running a race, how many ways can they finish the race? Well, that's 3 factorial. There's 3 factorial ways to arrange those 3 people in the order in which they finish the race. How many ways can you shuffle a deck of cards? Well, there's 52 cards in the deck. The number of ways you can arrange them is 52 factorial. Now, we said that 4 factorial was 24. How do we get that without drawing a diagram like this? As you can imagine, the diagrams get quite hairy when we get a large number of objects. Well, let's just think about what we did here. In the first choice that I had for my first marble that I selected, there were 4 possibilities because I started with 4 objects. Now, once I've picked the first marble, there are 3 marbles remaining. So for each choice, each of the 4 choices for the first marble, there were 3 for the second. So 4 times 3. If I count the branches out to this position, there are 4 times 3 of them. Now, once I've picked the second marble, there are 2 options left for the third. So the number of ways we can pick the first 3 marbles is 4 times 3 times 2. And then once I've picked those 3, there's only 1 choice for the last marble. So the number of possible ways I can get to the end of the arrangement is 4 times 3 times 2 times 1. And that's how we can mathematically compute 4 factorial. 4 times 3 times 2 times 1. And in fact, this is the formula for n factorial in general. So n factorial is n times n minus 1 times n minus 2 times n minus 3, all the way down. We keep multiplying until we get down to 1. Or we can reverse this because multiplication is commutative and associative. We can rewrite this as 1 times 2 times 3 times 4 times ... all the way up to n. So these are the ways that we define n factorial. So the number of ways you can order 3 people finishing a race, it's 3 factorial. It's 3 times 2 times 1. It's 6. The number of ways we can shuffle a deck of 52 cards, 52 factorial. That's 1 times 2 times 3 times 4 times, keep multiplying until you get to 52. How big is that number? Try it on your calculator. You'll see you'll probably get an error. It's not because that number doesn't exist. It's because that number is so huge that it doesn't fit in your calculator screen. Your calculator may give up. It may try to report the answer in scientific notation. This is the number. This is 52 factorial. This is an amazingly huge number. This number exceeds the number of atoms in the Earth. Right? That's how big this is. And if you think about that, that's crazy. There are more ways to shuffle a deck of cards, just 52 cards, than there are atoms in the Earth. Than there are grains of sand on every beach on Earth. It's a huge number. Factorials get big very fast. But the point here is, this is how we can count how to arrange n objects. It's n factorial.